Hi and salam sejahtera to Madam Fazila and all my friends. My name is Khai Nern with the matrix number of 285819. Now I'm going to present to you STQM2103 Discrete Structure Group Assignment Presentation with the topics of equivalence relation. Before we're going to dive deep into this topic, we must first understand what is equivalence relation. Equivalence relation is a relation that is represented by art that we can qualify it is equivalence with if and only if it has three elements, which is one, reflexive, second, symmetric, and thirdly, transitive. An equivalence relations is like a special group of friends who have unique bond. To be in this group, three things need to be true. First, they are friends. Second, they are mutual connections. And thirdly, equal treatments. First off, they have to know each other. Let's say you're friends with somebody at a party if you have a conversation with them. And secondly, how is it we call it mutual connections? If you are friends with someone and that person is friends with another person, acquaintance, then you are indirectly connected to that person too. This means there's a connections between you even if you are not directly friends. Thirdly, equal treatments. If you are in this special group, you are all treat each other the same way. If you share a secret with one of them, they share their secrets with you too. We're going to see into final examination papers of STQM2103 Discrete Structure. There's two set of questions I prepared here, which is from 2017, and another question is 2022-2023. According to the question 13, let the set B set of 5, 6, 7, 8 and relation art is equal to relation 5, 5, 7, 7, 8, 8, 5, 8 and 7, 6 to be on set B. Now we're going to construct the metric representing a relation art, which is my. So matrix of y. Now the question asks us to produce a matrix of relation for the above relation, right? Okay, this is the matrix that I've been produced just now. How can we determine there's how many one in a row or how many zero in a row or column? Firstly, we're going to look into the deeper part, which is we're going to see according to the relation given based on here, that the first subset we have 5 5, which is the reflexive numbers of 5. So we're going to put 1 according to the subset that has on the matrix. So there's 5 5 here, we put 5. 7 7, there's 1 here. 8 8, okay, there's 8 8 here, so we're going to put 1. 5 8, 5 8 here. 7 6, okay, there's 7 6 and 7 7. So other than the stated subset value, there's null or there's no number inside the matrix. So other than that, we're going to put 0. Okay, so we got the matrix numbers of y. Now we're going to the second question B, which is draw the diagram of art. So the question asks us to draw a diagram of relation. So before we draw the diagram, to look upon the matrix, we want to draw the relation. We're going to see according to the matrix created respectively. There's a 5 5, so we're going to put a 1 verticals here that has 5 and 6, there's 6 verticals here, 7 and 8. So according to the matrix, there's 1 on the 5 5 in representing reflexive, so we're going to put the arrow that goes outward and into the 5 itself, representing reflexive. And then another one, we have 5 8 here, row 5 and column 8, so we're going to put 5 that goes to 8, 5 that goes to 8, 5 goes to 8, okay, here. Then another one, we have 7 7 goes to 6, 7 goes to 6, this one. And then 7 goes to 7. It goes out and goes back to itself. 7 to 7, reflexive. Then lastly, we have 8. 8 times 8. The 8 goes back to itself. It means it reflects itself. So this is it. Now we have the diagram of relation of art. Okay. The next one, we're going to find the in degrees and out degrees of all verticals. So I prepared a table here as follows. For the rows of the above column, table, we put 5, 6, 7, 8 representing each verticals, and we have in and out degrees representing the in and out degrees of the arrow. So according to the above diagram, how many in degrees for 5? Okay, there's in degrees for 1 reflexive, and for the out degrees there's 2. Why? Because the 5 numbers goes outward for 2 times. Okay, this one and the second one is this one. The out and in degrees count as 1 also, yeah. So there's 2. For the 6 verticals, there's 1. Because why? Because the 7 verticals of 7 actually goes out to 6. So it means that the 6 achieved or received one arrow. So that means it has 1 in degree. But it doesn't have out degree because it doesn't produce outward. Alright? Okay, for the verticals of 7, there's 1 in degree and 2 out degrees. Okay, I see here there's 1 out and sorry, it's actually 2 out and 1 in. 1 in and 2 out. Okay. So for the verticals of 8, there's 2 in degree because this one counts as 1 and for the 5 to 8 counts as 2. So there's 2. However, for the out degree, there's only 1 because it goes out and goes back to itself. So there's only 1 out degree. That one. So by that we already achieved the question for C. Alright. Now we're going to the final examination of subset 2022-2023. So as the given question, it says that given the diagram below, such as this one, okay, this diagram, we're going to find relation R, find matrix relation, and determine whether it is a equivalence relation or not. Okay, I've done the question and the answer is as below. Now we're going to find a relation R. Okay, what is relation R? Actually, we have created a table. We actually have a diagram. So according to the diagram, we must draw a subset or set, I call it, of this one. Okay, so the relation is as according to this one. Okay, which means based on this diagram, we can actually create a relation for each of the verticals above. So there's 1 1 here. 1 go back to this one, so it reflects it. So there's 1 1. It has 1 2, 1 5, 1 5. 1 goes to 5. Okay, this one 1 5. So we've done for the relation of row 1. Now we're going to row 2, right? Row 2 and column 2, vertical 2, sorry. So how many does it have? Okay, we have 2 2 here. We're going to put it in the back one. We have 2 goes back to itself. Sorry, we cannot clearly see this one. Okay, so there's 2 goes to 1, so there is this subset 2 1. Right? I'm going to zoom out a bit because we can see clearly. Okay, 2 1, 2 1 here, 2 2 here. Okay, and 2 5. 2 goes to 5. Okay, that's all for vertical 2. Now we're going to the verticals of 3 right here. So 3 3 here we have 3 3. We have 3 4. Okay, 3 4. We have 3 6. Okay. Now there's the 3. Okay, we already achieved for 3. Then we're going for the verticals 4. So 4. Okay, 4 goes to 3. Okay, 4 goes to 3. This one. Wait, goes to 3. Alright. 4 goes to 4. Where is it? 4 goes to 4. 4 goes to 4. Okay, actually it reflects itself. So we're going to put it here. So 4 goes to 6. Okay, here we have 1. Other than that, okay, we actually have 3 only subset for that one. So now we achieve for the relation of 4, the vertical of 4. Now we're going to vertical of 5. How many 5 has? Okay, first we're going to see, okay, actually it's 5 5. 5 5, okay, here. 5 goes to 1. 5 goes to 1, okay. 5 goes to 2, okay. 5 goes to 5 itself. So there's 3 relation here. Okay, 5 5, 5 1, 5 2. Okay. Then we go to the last vertical, which is 6. 6 3. Okay, we have 6 3 here. We have 6 4, and we also have 6 6. So there's 3. 6 3, 6 4, and 6 6. So that's it. This is the relation for R. Okay, thank you. Now we're going to find the matrix of relation for this diagram. So this is the matrix of relation of the diagram I produced. So actually we can see here that it actually have a reflexive elements. Why? Because it has 1 in its main diagonal of the matrix. And then for the transitive part, we're going to check is it transitive or not. So actually, according to the research I've made just now, it is a symmetric relation. Why? Because we're going to see one by one. Okay, for the column of 1 and 2, 2 and 1, there's 1 1. Okay, you must remember that for symmetric relation, how can we know if it is only symmetric? So A must be B if and only if and only if is B equal to A. So now, according to this rule, we're going to see here. We will check either it is true or not. So for the 1 3 and 3 1, okay, it's the same value. Okay, so it mirrors each other. 4 1 1 4 0 0. 5 1 1 5 1. Okay, the next one for this one 6 2 0 2 6 0 3 6 3 1 3 6 1 3 6 4 1 and 4 6 1. So the last one 6 5 and 5 6. So it is all have a symmetrical relations. So thus we can say that it is a symmetric relation. For the last one, we're going to check is it transitive or not. So now I already produced a 2 matrix that multiply with each other. So the final result is we get a new matrix that multiply the result of the multiplication of both of these metrics that we multiply, we actually got the same value as the initial matrix. Okay, 1 1 0 0 1 0 1 1 0 0 0 1 0 and so forth. So we can say that it is a transitive relation. Thus, because when mr square times each other, it got the same value as nr. So it is a symmetric relation. So when the three elements has each other, so we can say that it is a equivalence relation. Okay, that's all for this question. And thank you to all that lending your ears to understand this how we can solve exact equivalence relation. So by that, I want to conclude my presentation for today. Thank you all for listening to this channel, and see you all again. Thank you and have a great day. Bye bye.